This is 2008 AMC 10B problem 24. Quadrilateral ABCD has AB equals BC equals CD, and the measure of angle ABC is 70 degrees. The measure of angle BCD is 170 degrees. What is the degree measure of angle BAD? Okay, so let's just start by drawing a diagram of quadrilateral ABCD. So we know that ABC is 70 degrees. Let's just draw that first. Now again, and we also know AB equals BC. Okay, so AB wait, no, it's supposed to be like this, I guess. AB and BC, and they're equal, and this is 70 degrees. And then the angle measure of BCD is 170 degrees. Now BC is equal to BC equals CD. Okay, and then we also have the other side, which is AD, and AD doesn't equal anything. Okay, so yeah, that's our quadrilateral. And we want the measure of angle BAD, so we want this angle. Let's call this X, because, well, we want it, so yeah. Okay, so what we're going to do now is notice that this side, BCD, this BCD thing, looks actually really like a straight line. And if we actually connect BD, so if we actually just connect BD, notice that we can form a parallelogram with sides AB and AD. This looks kind of like a rectangle, but it isn't. So if you're going to write this down in mathematical language, you're supposed to say connect BD. And like so say this point was E. Let E be the point such that AD is parallel to BE and AB is parallel to DE. So what this means now is that thus ABED is a parallelogram because there's two sets of parallel sides, and that's the definition for a parallelogram. So if this is a parallelogram, we know that AB equals DE and AD equals BE, and these are also parallel. Yep, and since they're parallel, we know that the alternate interior angles are equal. But firstly, what do we know from drawing the line BD? So we zoom in, we have the line BD here, and BC equals CD. So triangle BCD is isosceles. So this triangle here is isosceles. And the isosceles triangle, the base angles are equal, right? So we know that angle CBD equals angle CDB. Since this is 170 degrees, this angle here is 5 degrees. And the other angle is also 5 degrees. Okay, this line is kind of bad. So like if we redraw the line, so that's 5 degrees. Yeah, and then we also know that ABD from the problem, it says this angle is 70 degrees. So this here is 65 degrees. And yeah, that's all we know. Okay. So through alternate interior angles are equal because AD is parallel to BE. We know that, or actually no, because AB is parallel to DE, because AB is parallel to DE, and alternate interior angles are equal. We know that angle ABD which is 65 degrees, equals angle BDE, which is supposedly now 65 degrees. But we know that this is 5 degrees. So the remaining part of angle BDE is 60 degrees. Okay, that's about what we know. But we also know that CD equals DE. These two sides are equal. It's literally on the diagram. So yeah. And what this means is that if we connect CE, which we're gonna do right now, if we connect CE, we have an isosceles triangle with this angle being 60 degrees. So that's just an equilateral triangle. So this is 60 degrees and this is 60 degrees, and CE equals to all the other sides we've labeled on the graph. Okay, let's look back at the problem. What do we want? We want BAD. So to get BAD, we want to get the angle measures of, well, angles in the triangle or angles in the quadrilateral, right? Okay, so let's try and do that. So, let's see. So, right now, we also know that BC equals CE because it's also labeled on the graph by us. So we've probably figured out some part in the problem. So the two base angles are again equal to each other. And yeah, so the two base angles are again equal to each other. And we also know that this angle here, angle BCE, is 360 minus 60 minus 170, which it's so 360 minus 60 is 300, and so this is 130 degrees. So the two base angles are gonna be 25 degrees each. And since this is a parallelogram, we know that angle BAD, which is our x, equals angle DEB, which is 25 plus 60. So x is 25 degrees plus 60 degrees. So x is 85 degrees, which is our answer. And let's see if x is in the answer choices. Well, yes, it is. It's C.